Hello and welcome to the Automation 1 version 2.3 motion control platform release update. EtherCAT is a company that solves your toughest precision motion and automation challenges. Automation 1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based hardware, and hardware-based drives for servo motors and other devices. In this video, you will discover new features available in the 2.3 Automation 1 release. This includes additions such as Automation1 EtherCAT to support, MachineApps full support, EtherCAT full support, velocity and current mode additions, the official Q mode support, as well as several improvements such as data visualizer, programming module, EasyTune, .NET API, and Python API improvements. Let's get started with the Automation1 EtherCAT. This is an enhanced compact linear servo motor drive with a motion controller. The Automation1 EtherCAT is a powerful machine and motion controller. It controls up to 12 axes over the Hyperwire fiber optic network. It executes real-time AeroScript programs and also can be communicated with the .NET, C, and Python APIs from Automation1. These, of course, are cross-platform for Windows and Linux applications. It also has industry-leading motion control performance as far as controlling a servo motor or a precision stage. It can control one AC brushless or DC brushed motor. Often AC brushless motors are integrated into the stages, and also has up to 400 watts peak power dissipation per phase. Onboard I/O expansion capabilities are available, although not pictured in this image. The Automation1 EtherCAT on a cross roller bearing stage demonstrated industry-leading performance. This is 0.12 nanometers of RMS in position stability. This, of course, was measured by a stage with a 0.4 micron incremental encoder. On an air bearing stage, which of course doesn't benefit from the high friction in the cross roller bearing, also achieved very good results. 0.90 nanometers of RMS in position stability reading on an air bearing stage. Moving on to the connectorization of the Automation1 EtherCAT, you'll see that the main motor supply and motor output are all in one single connector. To the right of that, you have your feedback for all of your stage signals and encoder feedback signals. You would connect to this from your PC or network over the Ethernet network. Also available is a connectorization by USB. And then you would connect to several other Automation1 drives over the Hyperwire network up to a total of 12 axes of control, so 11 additional axes over the Hyperwire network, which you only have an output here on this drive because the controller is actually integrated into this drive hardware. If you choose to purchase the expansion board, you would get the position synchronization outputs, the auxiliary encoder channel, and also analog and digital I/O. If you choose to expand with the EB2 option, you would, instead of the I/O, you would get the industrial Ethernet support on the top of the drive. So these two come with EB1 or EB2. The point-to-point I/O comes with the EB1. The industrial Ethernet I/O expansion comes with EB2. Standard on the drive will be the sync port for all options, and those are for communicating encoder data to and from other axes on the system. And of course, the safe torque off, integrated safety, and then of course the control power here as well. So that's the connectorization of the EtherCAT from EtherCAT. Let's look at a comparison versus legacy ML drives. Comparing this to the Ensemble ML, first of all, let's take a note that this is the in-place kind of replacement, Automation1 replacement product. And in the Automation1 version, the EtherCAT, the drive array is 67 times the size as what the ML brings to the table. And that also is coupled with a much faster drive data capture rate, 10 times the speed at 320 kilohertz. But please also note that these values are 64-bit values, not 32. So effectively 20 times the rate when you look at all the data, the throughput. Safety, yes, there's functional safety, STO. There's sine wave quadrature emulation. Latency is 4 times faster at 0.8 microseconds versus 3.25 microseconds. And then there's more encoder channel options and more PSO options. Highlighting that is 2 times sine wave inputs. So you can have primary and auxiliary sine wave encoder inputs, often required for dual loop multiplied control of a stage system. PSO options, you have the option of purchasing the 2 and 3 axis part speed PSO options, which were not available in the Ensemble product line at all. Moving on to the controller side of things, the Automation1 drive-based controller has several advantages versus the predecessor, the Ensemble. The first is that we have more axes of control available, 2 more axes. For all systems, you can get up to 9 user tasks to program and 1 reserve task. This is 5 total tasks more, and at least 4 more tasks for a user to use. So that's a big addition. Another big advantage here is that the servo trajectory rate at the controller is calculated at 20 kilohertz. Please note that the Ensemble tried to solve that problem by doing an interpolation, which was very nice and well received and ahead of the servo loop, but those were not calculated points like the controller actually calculates. The points are not interpolated. Look ahead and accelerated limiting is always included on the ISMC, the Automation1 controller. G-code programming is always available. Corner rounding, parts rotations, and retrace, those features are always available on all Automation1 controllers. They weren't even available on the Ensemble motion control platform. Then, of course, you have this key advantage of developing your application in the Automation1 Motion Development Kit, which is a much more advanced software tool than the Ensemble Motion Composer suite. Now, when it comes to ordering options, you have 1 peak current option, 10 amps peak. You have 3 different expansion board options. Either you don't need one, or you get the IO-based one that we just saw, or the industrial Ethernet-based expansion board as well. Those are the 3 options you have, EB0, EB1, or EB2. You have 3 multiplier options. Either you don't need an encoder multiplier, MX0, or you just need 1 encoder multiplier, that would be MX2. Or in the rare case you do need 2 multiplied encoder inputs, you can get the MX3 option and have 2 multiplied encoder inputs for 2 amplified sine wave encoders. When it comes to PSO, as noted, you see the 2 PSO5 and PSO6 options for part speed PSO, but you also can order the 1, 2, or 3 axis traditional Aerotech PSO based upon the encoder feedback, firing an output based upon actual distance traveled, position synchronized output feature. So plenty of options in the Automation1 IXL2E. Moving on to MachineApps. This is an HMI builder for the Windows PCs. In 2.3 Automation1, we have the first official release of MachineApps. And again, this is for custom user interfaces for Windows PCs. To create these interfaces, you would use the MachineApps Workspace. This is your design tool. And it is an Automation1-MDK ordering option. And it also shows up as a workspace inside of the MDK when you order it. Now you also get the MachineApps application with every installation of Automation1's MDK. That application allows you to connect to a controller's MachineApps launchpad when that controller, that Automation1 ISMC controller, is configured with MachineApps. Each launchpad opens 1 or several MachineApps. And this, of course, is available for PC and drive-based controllers. So it doesn't matter how you plan on deploying your ISMC, you can take advantage of these great new HMI tools from Aerotech, the MachineApps feature and toolset. Now, how do you actually go about making one of these things in the workspace? First, you would pick a layout. You would define your primary layout, which on the left-hand side, you'll see there's several different configurations. And then you would choose secondary modules, which are actually the side panes you see here, this side, and then the top. So this is your left hand and your top, and that is based upon the primary layout. You see the 2 vertical side-by-side module areas. When you get into the actual workspace after defining your layout, then you start picking some settings. You would name your machine app, pick icons and colors. This is how you deploy your own brand. More on that later. You would opt into touchscreen sizing if you want to deploy to a touchscreen monitor. And this is only in beta right now, so we're going to be doing some more work in this area. And you'd also configure your controller and application settings, such as showing the reset of board buttons, whether you want to register for callbacks. That depends on the type of application you're building, whether you want to show the immediate commands in this machine app or not. And then also what happens when you close the machine app. I enjoy closing it and returning back to the launch pad where I may have several machine apps and want to open up another one. Next up, you look at the modules section, and this is where you drag and drop your modules into place. As you can see on this screenshot, each area has a module defined, access dashboard, customizable buttons, programming, data visualizer. we've already dragged and dropped modules into these different module areas. Then you would save and activate. So up here, you can see it's in gray, but it says save and activate that on your controller. So this machine app has been laid out, it's been saved, and it's active on the controller of which we're working. Let's go module by module and see which features are available in each module available to you in MachineApps. First, the jogpad module. You'll see in the configuration, you can do things such as configure multiple jog groups. You can name each group. Each group can jog up to 4 axes. You can configure low and high speeds and distance. And then from the UI, which is what this background image is, it's actually a screenshot of the user interface that you would have on the machine app. You can choose whether you want the low or high speed, whether you want to jog in free run distance or distance hold mode. And then you can change between your different jog groups. So I can change from full machine to just XY only, which are my 2 named jog groups that you see here in the module configuration module. So this comes up and allows you to pick all your settings for how you want this to work in the UI. Next up, the data visualizer. Same idea, you have a configuration screen. Whenever you drag and drop that module into place, this will pop up, and then you just fill out these options. And then the output of that is that the user in the machine app itself would see this data collection screen. As you can tell, all the colors I picked in my branding are applied here to all of the push buttons. So you have some custom capabilities you can deploy. You can configure signals to collect. So you'd click on this and a signal configuration dialog would open. You can configure your plot layouts. You can configure plot customizations. And you can deploy user permissions for different features, such as open and saving plots, computing fast Fourier transforms, switching plot layouts, and changing plot options. Moving on to the programming module. This module, you can see in this image, the actual deployed module has the touchscreen settings enabled because we have the large push buttons here for the control of the actual programming module in the machine app itself. Here you can pick your user permissions. So what things do you want your user to be able to do when using this programming module? Well, here you have the options of create, save, edit, and build files, load and run programs, debug programs, and those are the 3 options you can opt into or opt out of in the programming module. Here you also have task status and variables and IO modules. There's not much to say here. You can add these to your user interface. And the only real permission to add here is editing access to variables and IO values. So you can say, yes, you can edit the value of IO. So here you see I have that permission enabled that you can do this. This toggle switch allows you to toggle the state of an actual digital output. So this gives you the ability for a user to do that. If you don't want users messing with outputs through this module, simply turn that off and your user will not be able to do that. Moving on to secondary modules, the Axis dashboard. It's not really secondary in use. This is a very often used module, but it's just secondary in layout, or it actually shows up on the screen. It's not part of your primary layout. So looking at the Axis dashboard, you can see again, this is in the touchscreen mode with the large buttons, making it easier for an operator to hit the right thing on a touchscreen. You can deploy user permissions such as enable and disable axes, home the axes, jog axes. This one might be quite popular because why allow the user to jog axes from here if you are also deploying a jog pad? Conversely, if you're enabling jog axis from this Axis dashboard, you might be able to forego the jog pad altogether. Custom configuration options include the data signals. You can configure what to display. Going on to the next secondary module, this one maybe warrants a little bit more conversation. These are your customizable push buttons. First thing I'll say about customizable push buttons is this is where all the fun starts. That's because this works really quite nicely with Automation1's AeroScript programming language, specifically the ability to deploy and build custom library functions and custom library files. So this is another training course for you, but you can touch base on Automation1 AeroScript's libraries. A user can create their own library functions in a library file and then include that library automatically with every reset of the controller. That means all the library functions that you have are now easily accessible in all of the text editors, all of the intelligent autocomplete tool sets, just as if they're native AeroScript functions. It's really a powerful thing, and you can actually only deploy the compiled library file. Therefore, if you're sending this off to a customer, maybe you're somebody who builds and sells machines or deploys them off to your production floor and you don't want people to have access to things, you can manage the original text file on your own and simply ship the compiled file, and that protects your IP, your intellectual property, and what you've developed, and keeps it secure. But it also at the same time gives the controller complete access to all the functions that you spent a good amount of work writing. Those functions become accessible in MachineApps. The same, IDE backbones that we use for the actual programming module are accessed here in the AeroScript command line interface. So all the intelligent autocomplete and such is accessible here, and you can simply put in a function that calls your library function and it executes with the push of a button in the UI. Let me show you some more. So custom configurations in this setup, and what's going to end up being either a horizontal or vertical string of software push buttons under your user interface. You can configure the number of pages of buttons. You can page through sets of buttons. You configure the number of buttons per page, up to 12 buttons. Here you see I have 2 pages. On page 2, I have yet to define any push buttons, but on page 1, I have 3. You can assign states and configure your display text, your background and foreground colors. The foreground is just a text on the button. The background is the color of it. The AeroScript commands to execute, as noted before, right here. Then finally, this condition. And this condition is a nice feature that you can set up a condition in which this state of the button shows up. So for example, my condition here, if the axis homed status item equals 0, this state will show up. So if my x-axis is not homed, the button physically changes and the function it calls physically changes in software based upon that status item. There's also inhibited stages or states. This up here is called new state, safety interlock open. This is an inhibited state. What that means is that this is a state in which the button will not be pushable if this condition occurs. And this condition is that I just happen to set it for an example, the digital output, I think 7 or 0 equals 1. So if there's a digital output equaling 1, either output 0 or 7, I can't see it in this image anymore, then you would default to this inhibited state for this push button. And that was just an example. You can make it one of several conditions available in this user interface for setting inhibited state conditions. And then your display text and your condition would change. Let's take a look at this. I have 3 programmed push buttons here, software push buttons from the customizable push button interface. This shows the default state of that push button. Next one is a condition-driven state where the x-axis is not homed and the button actually changes. And finally, an inhibited state where that digital output is set to 1. And then we enter into this gray safety interlock open state. So it's all 3 type of use cases. Now inside of the configure customizable push button editor, you can duplicate pages, you can duplicate buttons, you get validation for names and button conditions, you can reorder the button states, you can define inhibited states, and validation and auto completion for AeroScript command inputs is also available for you. Moving on, a couple more features of the MachineApps interface. First, let's talk about managing controller launchpad title, icon, and background. So you can put a title to the launchpad itself. This is not the specific machine app, but this is from where all machine apps are launched. You can create your own icon, and then you can pick a background, either a solid color, or you can actually pick an image from your PC to make the machine app background. Secondarily, here on this screen, this shows you that you can have active listed and inactive machine apps. So if you don't really want to use your machine app that you've created, you can just make it inactive and then it won't be accessible on the controller. And so this is a nice screenshot showing how custom branding is deployed using MachineApps. As you can tell, the Launchpad has my imaginary company, PJW Laser, wallpaper, and with 2 different machine apps that you can launch, a machine controller interface and an inspection app. And then also, if you look at the actual machine controller interface machine app, you can see that, my branding is on the push buttons. It's showing up on all the different module user interfacing, push buttons as well. And as the app message display function also has branding I decided upon showed up here in my user interface, which is quite nice. Moving on to something completely different, the EtherCAT Industrial Ethernet Network. So what is EtherCAT? It is short for Ethernet for Control Automation Technology. It is an industrial network protocol, and it is powerful because it was built on a very pervasive Ethernet physical layer and standard, and it addresses concerns such as rapid response time, minimal data requirements, and cost for implementation. And each EtherCAT slave device reads and writes to data frames on the fly. So this is what makes it very fast and responsive and powerful, is that it reads and writes as the data passes through each node on the network. Here's a visual representation of what that might look like. There is one EtherCAT master over here. This is being represented by a Beckhoff product line called TwinCAT, where it sends out information to EtherCAT slave devices, and those devices in turn read and write back out to the master their own set of information. This software screenshot here shows the inside of the Automation1 Studio environment, where you can set up a series of reals and integers as inputs and outputs, and that really defines what we call the EtherCAT slave interface, or ESI file, which is a profile of I/O that allows the master to understand exactly how to communicate to each individual slave device. So Automation1 EtherCAT has what's called a process data, I believe, space, and those are things that operate at a really fast level, and there's 64 integers and 64 reals in that space. This defines our ESI file. We have a minimum cycle time of 1 millisecond, so we're operating at a pretty fast rate of communication. And also some user experience features inside of our own software application include the ability to upload and download MCDs with or without the industrial Ethernet configuration. So that means if you want to duplicate your system quickly, you can just choose to download the industrial Ethernet configuration as part of your MCD file and then upload it on your next controller just the same way to duplicate your full controller architecture. Another thing that we've improved upon here is that the variable I/O module includes the ability to add industrial Ethernet items as favorites. So if you want to look at a couple drive I/O items, a couple industrial Ethernet items in one common screen as a list of favorites, this is now part of that architecture as well, which is really nice for checking out systems and commissioning them. All right, moving on to velocity and current modes of operation for our drive hardware. We added these modes to the analog control feature in Automation1. And this is when you use an analog input to control the velocity or current command of a drive. When you use these modes, you can use separate analog inputs to control velocity feed forward and acceleration feed forward, therefore giving you access to those features. The drives that have this include all of these iDrives and their standard drive variants that don't have the controller included, which is really nice. That means that as long as you have each one of these drives networked to a PC-based controller or another iDrive, they can operate in this mode. Next topic, official command queue support. The .NET API and C APIs let you execute AeroScript commands on the automation controller in a first in, first out process. This is really important because non-queued AeroScript through the .NET API includes delays between these commands. So the command queue is one way to reduce or eliminate those delays. See, the queued AeroScript instead queues up multiple commands on the controller to prevent overhead and prevent delay. So in this official support of command queue, some AeroScript commands are made available only in command queues. These are things that require look-ahead synchronization, such as move PT or move PVT commands. So for our .NET customers out there might be some more restrictions or some more items just to consider because of our forcing some of these commands into the command queue sort of model. But this is done for you to have success in executing those commands and not experience these delays that might stop your motion from performing the way it needs to. Other improvements in 2.3. First, we'll talk about the data visualizer improvements. Plot interactions in 1D and 2D. This I like a lot. If you click on this cursor here and move it back and forth, you'll see the 2D move along the trajectory that relates to where the 1D cursor is. That happens in reverse too. If you would click on the 2D plot and move that around, you'll see where the cursor should line up in the corresponding 1D time trace plot down below. So that's a very nice feature to have in this concurrent view of 2D and 1D data. It's almost like watching a movie. Improvements. You can now include reserved task signals when collecting data. You can specify the length of time instead of the number of points. So if you think in time, not necessarily data points, and then do that calculation for time based upon the signal period, this makes it much more straightforward for users who are thinking in time. You can overlap 2 or more time domain plots now, and then you can also open up a data file and plot only the data points that are present in the file, which is a very nice user experience improvement. On the programming module, lots of things to talk about here. Let's get started. You can now work with files on the MDK file system, and this is going to be really popular for our PC-based controller folks who want access to Windows. So our PC-based controllers are Windows-based controllers. They run on a real-time operating system in front of Windows, but on Windows PCs. And our drive-based controllers operate on Linux, so that's the difference there. Automatically open running AeroScript programs is a new improvement. You can enjoy automatic parentheses, brackets, quotation completions, and delimiter matching in the programming module. You can enjoy automatic indentation when you add a new line to an AeroScript program. You can open and run compiled AeroScript files. You can see task state information like task 1 program paused in the status bar. You can disable program execution line tracking, which means this yellow bar, which is on the line of code being executed right now, can just jump off your screen and your screen won't update to try to chase it down. So if you're running programs with thousands of lines of code that just run away, you might not want to try to follow that yellow line all the way down. Now you can choose to sort of just stay where you're at in the program. You can see a visual indication of white space characters, which I'm not really seeing here on this screenshot. And then you can differentiate the color of AeroScript preprocessors such as pound define statements and pound includes from comments. They used to be the same exact color in the graphical, in our user interface here. And now they have different colors, so you can tell the difference between them visually quite quickly. And then you can expand and collapse regions of AeroScript code. I wish I was showing it really nicely here, but if you had like a function, you could just collapse the entire function or loop structures and things such as that. Another thing that's really nice that I'll mention is that you can go split screen mode. There's a little up and down arrow right here where you can have 2 different screens now in 2 different places in the program, which is another nice programming module improvement. So lots of things to be excited about here from a user experience point of view. EasyTune improvements. EasyTune is one of those features that just works. Don't need to know a lot about it, but just know that in the 2.3, we improved how it works. We improved how it calculates gains and filters. So expect better performance out of EasyTune in this latest release of our motion control platform. The .NET API, we added the controller.connectUSB static method. This lets you connect over USB to drive-based controllers that's connected to the same Windows computer. We also added this new drive array read method. This lets you read the contents of the drive array from a device. Now you can compile more than one AeroScript source file at the same time from different threads. You could do things like execute an immediate command while you compile an AeroScript source file from different threads. And then you can access, and this is probably the headliner, although I listed it last, the .NET help at help.aerotech.com/automation1. The full .NET API overview is there. In Python beta, several improvements. We've added a controller configuration API. And again, Python API is still in beta. We're still figuring out the last couple of items. We expect to release this in non-beta in the coming months. You can enjoy an expanded console examples, which now include getting and setting active controller parameters. It also validates CAPI's version before calling into it. You can upload and download a machine controller definition file from the Python API. You can retrieve the drive array data, and you can connect to a drive-based controllers over USB. That concludes this motion control platform release update. Thank you for watching. I hope you enjoyed learning about all the new features available in the 2.3 Automation 1 release.